Hello and a very good morning to all of you. Today we'll be doing a chapter called Heron's Formula. Right? Now, most of you might be knowing that this chapter comes in class 9th of the CBSE. Right? And it is very important from the viewpoint of competitive exam. So what I'll be doing is I'll be dividing this chapter into two parts. One which will focus on the competitive exams and other which will focus on the class 9th final examination. Clear? Now let's proceed with the chapter. So most of you might be knowing that the general formula to calculate the area of a triangle is what? Half into base into height. Clear? But what if the base and the height of that triangle is not given? Then what do we do? Well, for that we have three separate formulas. That is number one, we have the area of an equilateral triangle, which is what? Root 3 by 4 square of the side. Okay. Second, we have the area of an isosceles triangle. What is that? 1 by 4 b into under root of 4a square minus of b square. Clear? Now you might be wondering what is this b and a. So let me explain. B is known as the base or the unequal side. And what is a? The length of equal sides. Clear? But again, mind you, if we are given the base and height of an isosceles triangle, it will be very easy to use this formula and calculate the area of an isosceles triangle rather than using this formula. But again, the areas from both the formulas will be same, right? Similarly, the case will be with an equilateral triangle. The areas from this formula, and if we are given the base and height of this triangle, again the area from both the formulas will be same. Clear? Now the third type, what is the third type? That is what we call as a scalene triangle, and that is what this whole chapter is about. The third part, a scalene triangle, a triangle in which all three sides are unequal. Let this side be A, this be B, and this be C. Clear? Now, how will we calculate its area? First of all, we'll find a value called S, which is known as the semi-perimeter. Clear? Then, what is the value of S? That is in a way a mean of all the sides. We add all the sides and divide it by 2. Clear? Then we use this S to calculate the area of this triangle. That is under root of S into S minus of A into S minus of B into S minus of C. Clear? Again, mind you, if we are given the base and height of a scalene triangle, it is very easy to find the area using this formula than this formula. This formula is only used when the base and height is not given of the respective triangles. Clear? Now, one very important thing I want to tell you, that in case of an equilateral triangle, right, for an equilateral triangle, there are three things which coincide or which are equal. That is altitude, the perpendicular bisector, and medians. Right? Clear? These three things will be equal for an equilateral triangle. Second thing, for an isosceles triangle, right? Let me explain you. If AB is equal to AC, right? These are the two equal sides, and what I told you that the unequal side is called the base, and I draw a median on point D. Then BD will be equal to DC. In an isosceles triangle, a median that is dropped on the base also acts as an altitude. It is very important point you have to remember that in an isosceles triangle, the median to the base is also acting as an altitude, and together you can club it and call it as a perpendicular bisector because it makes an angle of 90 degree and bisects the opposite side. Clear? Now, in the third case, a scalene triangle. In a scalene triangle, everything will be different. The median will divide it into opposite side, right? But it will be different from the altitude and the perpendicular bisector. Nothing of a scalene triangle will coincide when it comes to the median, altitude and the perpendicular bisector. Clear? Now let's proceed with our questions. The questions will appear on the screen. So now let's proceed with our questions, right? The first question is that if the length of the median of an equilateral triangle is x units, right, you have to find its area. So let's draw an equilateral triangle. A, B, C. This is the median, and you know that the median and altitude of an equilateral triangle are same. Let this point be D. Clear? Now for calculating the area you need the side. So let this be y unit, y unit. This will be what? Y by 2, as it is median and altitude same. So together they will be y. Now take a triangle, for example ADB, and what we apply? The 1000-year-old theorem called Pythagoras theorem. Right? The square of the hypotenuse is equal to the sum of the square of the perpendicular plus the square of the base. We group together like terms, and what we get is 3y square by 4 is equal to x square. Now what we need? We need the side. So y square will cross multiply and get 4x square upon 3. The square will get transposed to other side, and what it will become? It will become the root. So y is equal to under root of 4, that is 2. X square gets cancelled with the root, that is x, and root 3. Right? Now put it into the formula of the area, that is what? Root 3 by 4a square, or the square of the side. That will be 4x square upon 3. This will get cancelled, right? What we are finding? We are finding the area, and that will come out to be as root 3 by x square, root 3 by 3x square, right? We are not given the units, so square of the units, right? Now you can say this is also a standard result. If you are given the length of the what median of an equilateral triangle, you can simply find its area by using this formula. Clear? Now let's move on to the next question. Now in the next question, you are given the perimeter of an equilateral triangle. You are given the perimeter of an equilateral triangle as P plus 1 units, right? And you have to find the length of its altitude. Clear? All the three sides are equal, so the length of one side will be what? P plus 1 divided by 3, right? We'll divide the perimeter into 3 equal parts. This will be p plus 1 by 3, p plus 1 by 3. Now this will be what? P plus 1 by 3. But the altitude also bisects the side. So this side will be half of this, that is p plus 1 by 6. So will be this side. Again, using Pythagoras theorem, what we get in triangle ABD? We get square of the hypotenuse upon 9, right? The square of the perpendicular, let that be AD square itself, plus the square of the base. We'll group together the like terms and we'll get p plus 1 upon 36 whole squares here is equal to AD square. Now, proceeding further, we take the least common multiple, that comes out to be 36, 9, 4s are, so 4 p plus 1 whole square minus p plus 1 whole square is equal to AD square. This comes out to be 3 p plus 1 whole square upon 36, right? Now again, you know, the square will get transposed to the other side and this will become the root. Mind you, don't cancel this 36 with 3, because then in that case your denominator will be what? An irrational number, right? So the under root of 3 will be under root 3. This square will get cancelled with the root into p plus 1 upon what? 6 is equal to 80, right? So we have found out the length of the altitude, right? I hope it is clear to all of you. Moving further, now comes a little tricky question. I would not say tough, but tricky. Now you are given that you have to find the area of a right angled triangle, right, if the radius of its circumcircle is 3 units, or let us say 3 centimeter. Clear? Now, sir, what is the circumcircle? Simply a circle which touches all the 3 points of a triangle is known as the circumcircle, right? So let me draw a figure. A, B, C. This is more of an oval, but you take it to be a circle, right? Clear? We take the center of the circle somewhere as O. Let me little correct it. Something like this. Yes. This is O. That is what? Mind you, that is the center of the circle. This will be the radius. That means AO will be what? 3 centimeter. That will be equal to OC. And one thing you are given more, that the altitude to the hypotenuse is how much? 2 centimeter. Altitude to hypotenuse is 2 centimeter. Now just take a look at the figure. Stop, pause and take a look at the figure. You know that the basic Pythagorean triplet is 3, 4 and 5, which means that all right angled triangles are scalene triangle, right? So don't confuse that this 2 centimeter will lie on point O. No. Because O point divides the hypotenuse into 2 halves, and in a scalene triangle the altitude and medians don't coincide, right? Now what we have to find? The area. So we can simply write half into base into height. Now you might say that, sir, the base is not given and the height is not given, right? Now in your mind, tilt this figure. What is this? It makes an angle of 90 degree. So this will be what? The height. And where it makes an angle of 90 degree, on which side? That is AC. That is how much? 3 plus 3, 6 centimeter. So we have found out the area of our triangle. Base is how much? 6. Height is how much? 2. So this comes out to be as 6 centimeter square. Very simple. Just you have to remember the basic concept. I hope it is clear to all of you. So now, moving on to the next question we have. If each side of a triangle is doubled, right, you have to find the percentage increase in its area. Percentage increase in area, right? Now let me draw two triangles for you for comparison. Let this be A, B and C, and let the bigger one be P, Q and R, right? Mind one thing very carefully, that don't take it as an equilateral triangle or as an isosceles triangle unless until it is given. Clear? Now let the side AB be A, AC be B and BC be C. Similarly, now the sides will be doubled of the new triangle 2B and 2C. Clear? So by semi-perimeter of the first triangle we have A plus B plus C divided by 2. Clear? Very simple. And the area from the Heron's formula will be under root of S into S minus A into S minus B into S minus of C. Now let this whole area be equal to one single value. Let it be theta or alpha or beta or any other symbol which is convenient for you. Similarly, for this, the semi-perimeter will be different. So let us suppose it as S dash. Now we have 2A plus 2B plus 2C upon 2. Now very carefully remember, we will do a certain smart work. We will take 2 common from the numerator. So now S dash is equal to 2A plus B plus C upon 2. Clear? Now this all value is given to be as what? S. So let me put simply in its place twice of the semi-perimeter of the first triangle. Clear? Now its area will be what? Under root of 2S into 2S minus of 2A into 2S minus of 2B into 2S minus of 2C. I hope it is clear to all of you. Now what we will do, we will take 2 common from this, 1 2 common from this, 1 2 common from this and 1 2 common from this. What we will get is 2 into 2 into 2, 8 into 2, 16. Clear? I hope this step is clear to you. You can pause the video and recheck it again, right? So now I will write a simplified form after taking 2 common. I will be left with 2S into 8 into S minus of A, S minus of B into S minus of C whole under root, right? Now 2 into 8 will give me 16. The under root of 16 is what? 4. And I am left with S into S minus A into S minus B into S minus of C. Again, now these two things are equal to one another, and we have supposed it to be equal to what? Theta. So now we simply write it 4 into theta. So the area of the new triangle is 4 times the area of the original triangle. Clear? Now what we have to find? We have to find the percentage increase. So what we will do, the new area minus the original area upon the original area, because we are comparing it by our original triangle. To find percentage, what we do? We simply multiply it by 100. Now we are left with 3 theta upon theta into 100. It gets cancelled and 3 into 100 is 300%. Right? 4 times the area and the percentage increase is 300% from the original triangle. Now if the side is tripled, you can very well do it. Right? I hope it is clear to all of you. Thank you.